Perennial Agriculture Solutions, a necessary shift to healthier and more sustainable food systems. So real quick, the class outline, I'm going to offer a few quick definitions to make sure that we all understand what we're talking about when we talk about perennial crops, perennial plants. And then I want to make the case that farming or the cultivation of food has only recently, fairly recently, become dominated by this idea of annual grain crops. For the vast majority of our human history and in most places around the world, farming was a pattern of using diversified perennial production. And only recently we've embraced this large-scale shift towards annual crops. We're going to look at how that happened. I'm going to argue that it was a forced transition, mostly done by vested interests in states and corporations wanting to make the most of their investments in agriculture. And then we're going to take an in-depth look at some of the advantages, why perennial crops are better for the ecosystem, for our health, and for the small farming community. And lastly, and this is the part I'd love to hear your all's insight and your own experience, is some of the examples of perennial crops throughout the world. We're going to talk about there are somewhere between 300,000 and 500,000 different plant species that we know of in the world. There's probably more than that, a lot of them that haven't been discovered, hidden in the rainforests and mountain tops and all these different places. Of those 300 to 500,000, somewhere between 80 and 150,000 species of plants are edible. We can eat them. They provide nutrients to our human bodies. But as we'll see, the global food supply today relies about on more or less maybe between 80 and 100 crops, and only 3 to 5 of those crops, the main grains, rice, corn, millet, wheat, dominate over half of our agricultural production. So we're kind of putting all of our baskets into one egg, or sorry, putting all of our eggs into one basket, and ignoring the enormous diversity that that exists. Not only diversity in different plants, but all of the edible species that are available to us. So before we get started, I first came across this idea of perennial production as a solution, as a focus, as a legislative approach, how governments can focus and stimulate a production that is more perennial nature, from Wendell Berry, who's a farmer and a writer based out of Kentucky, which is the state where I grew up at in the United States. And about maybe 20 or 30 years ago, together with a friend of his who works at an organization called the Land Institute, they set forth what they called a 50-year farm bill. And they were criticizing the fact that the United States government every 5 years ced out with a 5-year farm bill, how they were going to invest in farming and farming communities throughout the world, throughout the country of the United States. And they were saying that these laws, these legislative proposals for farming, were extremely short-sighted. It was all focused on stimulating chemical production, monocultures, supporting the huge 50,000 acre farms growing monocultures of corn, investing billions of dollars in subsidies into this failed mode of production. And they said, what we need is to fundamentally shift our idea of how to create a plan for healthier and more sustainable agricultural communities. And he says, this is from their 50-year farm bill proposal. Across the world, around 20% of agricultural production is perennial and 80% is annual. We propose funding and political support to reverse that, so that in the next 50 years, our agricultural sector is made of production. And they base that statistic on nature, because around the world, perennials constitute roughly 80% of North America's native flora. If you go into a forest, you'll see around 80% of the plant life is perennial nature, and there's 20% annual. And so they make the argument that in order for our farm ecosystem to be healthy, to replicate, to mimic the natural world, we need to shift our emphasis away from annuals and back to perennials. So yeah, let's start with some definitions. What is a perennial crop? As a basic definition, perennial crops are plant species that are cultivated and live at least longer than 2 years, though generally longer, without the need of being replanted each year, right? So when we think, again, we think of farming, we think of people who grow corn or wheat or millet or rice. Every year, you plant, usually in the springtime, you till the fields, sow the seed, you water, you irrigate, you fertilize the fields, and then come the fall time, you harvest. Sometimes most people generally burn the refuse of that crop, let the field fallow for a few months, and then start the process over again. It's a cyclical thing, year after year after year, planting, caring for the plant, harvesting, and then starting over, tilling again. Um, Annual crops, in that sense, generally have led to an enormous amount of soil erosion. The process itself of tilling the soil year after year after year. If you go into nature and you look around, you will almost never see bare soil. The first thing that nature does is covers, the thin layer of topsoil where all of the fertility is hidden in some sort of crop, in some sort of plant or anything like that, right? And so that's that you don't see bare fields that is kind of one of the staples of annual production. Perennial crops are typically considered as those that are more permanent, requiring a number of growth cycles before fruit or nuts or whatever the food stuff might be is produced. I think that word permanent is important. We've talked, I did a class a couple months ago about the idea of permaculture, permanent agriculture. And I think most traditional farming methods around the world have focused on how to create agricultural production systems that allow a group, a family, a culture to subsist in a place over time, right? Only our modern day agricultural systems have kind of shifted the focus. What we do now is we mine the soil. We don't care for the topsoil. We use it up as quickly as possible. We mine the fertility of the soil, and when the soil fertility is gone, we move on to the next place. It's the pioneering mentality that's kind of taken over agriculture. Whereas in the past, people were always trying to discover ways to live permanently in place. And one of the things that they understood very quickly was that to do that, we needed to take care of the soil fertility. We needed to take care of the land that sustained us, of the water sources, and finding ways to cultivate perennial crops as a pathway towards perennial agriculture was one of the main ways to do that.
Tobias, there's a question here that's kind of important. Do perennial plants give food production every year?
Yeah, that's a good question. So here it says perennial crops generally takes a little bit longer to get started once they want to start producing. But yes, in general, once they start producing, most perennial crops will produce every year. There are obviously some differences. For example, some nut trees, pecans, which is a famous nut tree in the United States, generally have production every 2 years. They have a huge crop one year, then rest a year, and then go back another year and reproduce. But in general, most perennial crops will produce, whether it be fruit or nuts or grain, whatever it might be, on a yearly basis, right? It's just the moment of getting it started, the initial period of starting the plant. For example, if you plant a fruit tree, the first year as a sapling, you probably won't get any production. The second year will start to grow out, depending on the type of fruit. The third year, you might see a small production, and then the fourth and fifth year on, you will get higher levels of production. I think it's also important to understand that perennial crops are not just fruits. I mean, a lot of people think of apples and mangoes and bananas as perennial crop species. But no, there's all sorts of different types of perennial crops. Plants that you plant once, take care of, and then reap annual harvests, right? There's fruits, obviously. There's all different types of nuts. Grasses. Grass is a perennial crop. I think that's very important. Obviously, we don't eat grass. We don't have a multi-chamber digestive system, but we can raise ruminants like cows and goats and sheep that can eat that grass and turn it into dairy products and meat products for ourselves. There are several different types of annual grains. A lot of people don't understand that, but there are several types of annual grains. that we can eat, that we can survive off of. Vegetables. Here in this picture here, you'll see several different types of perennial vegetables. We have artichokes, rhubarb, Jerusalem artichokes. Over here is asparagus. All of these are different examples of vegetables that you plant once and then harvest for several years. There are herbs, there are flowers, there are oil-producing plants. Despite making up 94% of different types of plants on Earth, perennial crops only take up 13% of global cropland. I put the statistic in here to show that I think that there is an enormous amount of diversity that we're missing out on, right? That our agricultural systems have not learned to implement. There's an enormous amount of perennial crops that we can grow, but that we simply do not. So yeah, I said in the beginning that perennial production used to be much more widespread than it is in modern times. And I think that there's a kind of a common sense kind of explanation for that. You know, monocultures, like I said, do not exist in the natural world. You will not go into any natural ecosystem and see just one type of plant. You know, you can go to a tree plantation, of course, and see miles and miles of pine trees or eucalyptus trees. You can go to the Midwest of the United States and see miles and kilometers of just corn and just beans. But in the natural world, diversity is always the key. You will always see a diverse array of plants and animal life. As our ancestors, about somewhere between 5,000 and 10,000 years ago, began to slowly transition from hunter and gatherers to more settled agrarian communities, they discovered that there were hundreds of perennial crops. Think about it. You're a hunter and gatherer. Over several generations of walking through your traditional territory, these hunter and gatherers understood, had an extremely in-depth understanding of the native plant community, of all of the different crops. They knew when they flowered, when they went to harvest. They planned their nomadic movement around this. And then slowly, some of them started to understand that they could take these roots, these seeds, these fruits, these nuts, and plant them in certain areas and maintain those. One of the oldest crops that is known to have been cultivated, some people say that up to 28,000 years ago, so 3 times longer than what most people think of as the transition to agriculture from hunter and gatherers, is the taro root. Here in Latin America, we call it malanga. I have some growing. It's a huge, highly nutritious potato or tuber that grows in wet soils. It is by far perhaps the easiest crop to grow. You plant one tuber, and around that tuber, several different sucker plants grow up that you can easily separate, plant out. As soon as you harvest one, you can put the top of the plant right back into the ground and it starts to grow another tuber. And people understood this. They understood that it was easier to grow, to transition to more sedentary communities by finding these crops that were easy to grow, that had a perennial nature to themselves, right? This idea of planting and harvesting, saving seed, and then planting again, that came much later. The transition to agriculture started because of the enormous amount of knowledge and wisdom that these hunter and gatherer tribes had about the growth characteristics of mostly perennial crops.
Okay, Tobias, can I ask just a quick question?
Yeah.
You'll probably cover this later on, but you're saying that perennials are like low cost and they're easy to grow. Why do they, for example, do they use less oil and gasoline to produce?
Yeah, definitely. We're gonna look at why we transitioned.
Yeah, because I'm really curious as to why agriculture doesn't use low cost food production.
Yeah. You kind of jumped the gun there, I'm going to talk about that, but as a quick response, I'm going to say that one of the reasons that we do that is because there are definitely vested interests today in monocultures of annual grains. Some people are making lots and lots of money off of it, we'll say. So I think we're going to talk about that here in just a second. But yeah, annual perennial crops are certainly much cheaper. They're generally easier to grow once you get them established. There's less labor involved. The annual Anybody who has farmed knows that the annual work of tilling the soil, planting the crops, weeding the crops, harvesting the crops, threshing the crops, and then starting all over again next year is an enormous amount of labor. Perennial agricultural systems take time to get established, but then there's less weeding involved. You don't have the annual tillage of the soil. It's mostly maintenance and harvesting, right? And then there's a lot of myths also about the first civilizations. There's this idea that people transitioned to growing monocultures of corn and wheat and other crops like that because it was supposedly easier and more abundant. Here in the part of the world where I live, there's this idea that the Mayan people subsisted on only corn, and there's all these ideas of us as the corn people. But if you go into traditional Mayan cultures today, and if you look at some of the historical records, that's just simply not true. People did grow corn, obviously, but they also had what's known as forest gardens, this is a picture of one of my neighbor has a small forest garden, and it's an unplowed, tree-dominated agricultural field. You walk into it, and you feel like it's a jungle. It's not necessarily easy to pick out. It doesn't have ordered rows of one crop and things like that. It looks kind of like a wild system, but within that system, there is an enormous amount of food production. There are high canopy trees producing fruits and nuts. There's lower canopy trees. There's bananas growing underneath that. There's vines winding up the tree that give fruits and nuts. There are tubers growing underneath the system. There are fungi, mushrooms that are edible that are popping up. But it creates a diverse array of plants to meet human needs. It gives us food, obviously, shelter, medicine. It's maintained with local resources such as compost, dead weeds, ashes from kitchen fires, manure, et cetera, et cetera, et cetera. And this is kind of what sustained traditional Mayan communities, throughout their history. But there's this idea again that as soon as civilizations popped up, we kind of shifted away from our dependence on all of these perennial agricultural systems, and we started to focus only on growing corn, on growing wheat, whatever it might be. And I think that that's simply not true if you look at the historical record. Another really interesting example is the Amazon rainforest, one of the most diverse and the largest rainforest in the world. And a lot of people for a long time thought that this was nothing more than just years creating this enormously diverse, beautiful system. In 2003, there was this really in-depth study done by a number of anthropologists and plant biologists, and they found they sampled all sorts of different plots of land throughout the entire Amazon forest basin, and they discovered that there were more than 16,000 different species among the 300 billion individual plants in the Amazon rainforest. But then they noticed that there was something odd. Despite this enormous diversity of plant life within the Amazon rainforest, over half of the total trees that made up the rainforest itself were made up of just 1% of the species, 227 different types of tree species. About 20 of those were these what they called hyperdominant plants, and they were edible species. The Brazil nut, the Amazon tree grape, also known as jabuticaba, the ice cream bean tree. These are just some examples. And these trees were about 5 times more likely than what would have happened just by natural selection. It didn't make sense that just 1% of these tree species seemed to be specifically cultivated. And what they determined was that all of these indigenous groups moving throughout the Amazon rainforest selected these trees because they were healthy, because they created an abundance of food for the different tribes that have been living through this. So the Amazon rainforest, much of it is a cultivated landscape. It's an example of perennial agricultural systems managed, taken care of, protected by indigenous groups over thousands and thousands of years. So again, going back to Dr. Lambert's question, if perennial agricultural systems are so abundant, are generally easier to take care of, are better for the natural world, why did we transition to perennials? James Scott is an anthropologist who has written a lot about this issue, and he wrote a book called Against the Grain.
But I think you meant to say, why did we transition to annuals, correct?
Yes, sorry.
You said perennials.
This isn't correct. You're right. Yeah, why did we transition from perennial food forests, perennial tree crops, to annuals of grains mostly. And James Scott says that it is important to distinguish between state crops, when he's talking about the birth of modern day states, the birth of civilization, like rice, and state evading crops like cassava and potatoes. He argues that states depended on annual grain crops on fixed fields, and that populations wishing to evade taxation and state control adopted subsistence strategies such as root crops, swidden, shifting cultivation, hunting, foraging, dependence on the naturally occurring perennial crops to place themselves outside of state control. He argues that for a state to exist, obviously it needs some sort of tax revenue, right? And in the early days, that came from excess surplus agricultural production. And in order to create a state, you need to know who is growing what, how much grain, how much production is happening, and how they can tax that. Right? That's not easy to do, in a food forest, in these perennial agricultural systems where there's just an enormous amount of abundance. When you have one field where the amount of production, the amount of harvest can be weighed and measured and calculated, then it's much easier to control a large amount of the population. Because fields were fixed, the crop ripened over a short period of time. It was impossible for the farmer to avoid the tax collector. Just the rise of this nation state model, the rise of civilization, of these large urban empires that extracted value from the farmer, from the resource-based community, was responsible in the beginning for this large-scale shift to perennial grains that today dominate global agriculture production and global diets. That I think that's a historical example of thousands of years ago. Why did our ancestors were they just not very smart? Leaving behind these extremely abundant systems to put all your eggs into one basket and just grow one crop of corn, one crop of grain. No, I think there's a lot of anthropological evidence that this model was forced on them by the nascent states, the beginnings of civilization. The elites needed somebody to tax. And the easiest way to tax people in the beginning was to make sure that they were growing one crop that could be easily measured and subsequently taxed. In more modern times, what we get is the whole green revolution, right? So back in the 50s and 60s and 70s, in the post-World War II era, there was this idea that we were having this ballooning population, this enormous explosion of population growth. And there was this whole idea that we need to feed the world. In order to do that, we need to drastically increase the amount of agricultural production through chemical fertilizers, chemical pesticides. In short, a shift to industrial monoculture agriculture. In 1973, one of the main proponents of this agricultural model, Secretary of Agriculture named Earl Butz, told American farmers that they needed to plant fence row to fence row, one species of grain crop, and he told them to get big or get out. Get big meaning make this transition away from diversified perennial crops to monoculture grain, or stop being a farmer. And that's exactly what happened. And that's what's happening around the world today. It continues to happen in developing nations, that small-scale farmers are forced out by government subsidies. For example, the United States, more than $30 billion a year is spent by the United States government on subsidies for farm businesses. And just USDA livestock subsidies over $59 billion. This is a forced maintenance of a annual grain agricultural model. At the same time, as I've said in several different classes, this seems to be a completely failed governmental policy. According to the UN FAO, the Food and Agriculture Organization, family farms produce 3/4 of the world's food. Much of that production still comes from perennial crops. The FAO also estimates that almost 3/4 of all farms are smaller than 1 hectare. So small farmers today, those who generally continue this tradition of diversified perennial production, are the ones who are continuing to feed the world, despite the fact that all of the money continues to go to these massive monocultures of annual crops. Okay, so let's take a look. Why? What are specifically, scientifically? What are some of the benefits of perennial crops? One, erosion control. If you're tilling the soil year after year after year, that exposes the soil, then it rains, it gets windy, and that really thin layer of topsoil upon which all of our livelihood, our human well-being depends, essentially is evaporated. It gets washed into the rivers, washed into the oceans, blown away, and there's extremely frightening statistics at how much topsoil we've lost over the past decades. If you look, for example, perennial crops can remain in place year round. Topsoil erosion due to wind and rainfall is reduced. Secondly, water use efficiency. Because these perennial crops tend to be much deeper, the roots are more fibrous, much thicker than annual crops. They're able to hold soil moisture more efficiently. So that means if we have a several month long drought, for example, here in this part of the world where I live, we have 6 months of rain and 6 months of dry season. If I tried to not water my cornfield for 6 months, obviously the corn would shrivel up and die. But all of the tree crops that I have don't. Uh, those, once they're established, their root systems go extremely deep into the soil, are able to access all of the groundwater sources that other annual crops cannot. They filter pollutants. Example. So if you look at this picture over here, this is a picture on the right hand side over here. This is a wheat crop, and this is an annual grass. And just look at the difference in the size of the roots between an annual grass and wheat. And obviously that gives you a little bit of idea about how perennial crops can certainly help to slow and even stop any sort of erosion. Secondly, another advantage of perennial crops is that they're able to cycle and access nutrients much more efficiently. Because perennials more efficiently take up nutrients because of their deep root systems, this means that they need less amounts of nutrients. So, for example, if you have, go back to this picture, if you're growing wheat, wheat only can access nutrients in the soil at this very superficial level. Due to the fact that most agricultural soils have lost an enormous amount of fertility, what most farmers then do is supplement that by adding an enormous amount of synthetic fertilizer that then is washed into that is lost and is washed into the rivers, causing acidification, causing these algal blooms throughout our water bodies. Whereas perennial crops, like you see here, have much deeper root systems. They're able to access nutrients much deeper than the annual counterparts. If you look at this picture here, for example, also perennial crops generally produce their own fertility, right? A fruit orchard or a nut orchard that's diversified, the annual litter fall, the leaves that fall and decompose, this contributes to this enormous diversity of soil microorganisms that create fertility for the crops itself. Secondly, I think this is important to know also that perennial crops, especially tree crops, are much better at essentially taking advantage of the free energy of the sun. We know that all crops have the ability to photosynthesize, which is essentially take the energy from the sun, turn it into carbohydrates for the plant. But not all plants do that the same. And generally, the annual crops that we depend on, like the annual grains, are not nearly as efficient at taking the free energy from the sun and turning it into soil, into energy for themselves, right? Whereas tree crops and other perennials, as they grow, are able to do that much more efficiently. Trees develop generally leaf out much earlier in the season, so they're able to start generating their own energy earlier in the growing season. They have longer green leaf duration, increase the seasonal light interception, et cetera. So essentially, perennial crops are more efficient at capturing energy and turning that energy into food than their annual crop counterparts. Another thing that I think is extremely important is that when we talk about annual production of grains, every year when you're plowing the field, every time you plow the field, that releases an enormous amount of carbon dioxide from the soil that then evaporates up into the atmosphere. Every time you burn the refuse from your corn crop, from your wheat field, that also releases carbon dioxide in the air. Perennial agricultural systems have the ability to sequester carbon. That means to take the excess amount of carbon dioxide that we have in our atmosphere right now and store it into the soil. It can also store, obviously, a tree is a type of a storage mechanism, right? All of the different wood and leaf and all of that is a way to store carbon. But even beyond that, as trees grow roots, as they contribute organic matter to the soil, a lot of this organic matter mineralizes and it gets stored as what's called SOC, soil organic carbon. And there's a lot of studies going on about how much soil organic carbon, if we were able to refertilize through natural strategies, all of the topsoil that we've lost, all of the degraded soils throughout farmland around the world, there's a lot of estimates that we could essentially solve climate change. Store the excess carbon dioxide that we've released through burning fossil fuels into rich, nutrient-dense soils, right? Through mineralization and immobilization of carbon compounds by microorganisms, all of these millions of little tiny creatures take the carbon from leaf fall, from branches that fall, and turn it essentially into minerals that create healthy topsoil. Obviously, if you're able to sequester an enormous amount of carbon, we can respond to global climate change. Perennial species have been shown to provide a great opportunity for mitigating or even reducing the negative effects of climate change. Today, as it stands, the agricultural sector is responsible for an enormous amount of carbon emissions. If we were to transition to an 80% perennial agricultural model, it's fairly easy to say that our agricultural system could become carbon negative. That is, that it sequesters much more carbon than it produces. And lastly, two other, I think, important advantages of shifting to more perennial crops is that we're going to have healthier, more diverse diets. Today, only about 30% of crop species make up 90% of the calories in our diet, and only 3 species, rice, wheat, and corn, account for half of the human calorie supply. Again, that doesn't seem to me to be very intelligent, right? We should not be putting all of our eggs into one basket. I don't know if anybody's seen a movie that came out called Interstellar. At the beginning of that movie, it talks about space travel and time travel and all these things. But at the beginning of this movie, I think it shows kind of this prophetic example of what happened if all of global agriculture came to depend on just 1 or 2 or 3 crops. And we're moving that way. And what happened was that those crops inevitably began to fail and put human beings in an existential crisis, right? And over the 20th century, we've lost 70%, 75% of our crop diversity. So obviously, the more food that we can grow, the more different types of species we grow, the healthier we're going to be, and the healthier our ecosystems are going to be. And lastly, when farmers have more control over the crops that they grow, this leads to increased autonomy and food sovereignty for small farmers. If one crop fails, you're not going to be completely lost, right? Whereas if you're growing just corn or just wheat or just rice, if something happens, if a drought hits, if pests come in and you lose your crop, then you're indebted to the bank and people lose their land, and this is kind of the cycle that happens to small farmers. Whereas if you have a diversified perennial agricultural system, if one crop fails, you have something else to fall back on. You're not purchasing the enormous amount of inputs from chemical fertilizers and pesticides, et cetera, et cetera. To end here, I want to talk a little about we got about 5-10 minutes. I want to talk about some examples. One of the unique aspects of perennial agricultural systems is that they can adapt to every different type of ecosystem around the world. It's not something that just can exist in tropical climates, not just in cold climates. In North America, in colder climates, in Wisconsin, which is in the northern part, the colder part of the country, there's a farmer called Mark Shepard. I went and visited his farm a couple of years ago. He wrote a book called Restoration Agriculture. And his beautiful farm, you can see in the background here, he's created this extremely diverse system of growing mostly fruits and nuts on contour. And in between each kind of row of trees are perennial grasses, where he has different types of livestock, pigs and sheep, that he rotates through these basically these orchards. So he says that restoration agriculture explains how we can have all of the benefits of natural perennial ecosystems and create agricultural systems that imitate nature in form and function while providing for our food, our building, our fuel, and many other needs. So in his part of the world, that the natural ecosystem is an oak savanna biome. So he said, okay, we can't, oak trees, there are some edible species of acorns, but what other species that are similar to the oak tree could we implement? So he started implementing hazelnuts and chestnuts and walnuts and apples and elderberries, all of these woody crops that are extremely abundant. And he planted along a key line to manage water. He planted grasses so that they could have a source of meat through the different types of livestock that he rotated through these systems. And instead of be beautiful, perhaps he has statistics on his website about how many more calories per acre his model provides than if you were just growing corn or just growing soybeans or whatever it might be. And it's something like 20-1. So he's producing 20% more or I guess 200% times more calories per acre on this diversified perennial system than if you were to kind of follow the monoculture annual species with mostly corn, which is what's grown in his area of the world. In the tropics, there's this kind of natural tendency for things to grow like crazy, right? You have heat year round. There's year round growing season. And one of the things that I think naturally exists in tropical areas is the idea of a food forest, right? So this idea that instead of growing just one crop on one layer, what traditional farmers, going back to the Mayans, but this is something that I think has existed throughout the world, is that people understood that you could grow different crops on different layers, on different strata, right? So the food forest, generally, when we talk about that, we talk about 7 different layers, right? You have these big trees, which are large fruit nut trees. Could be a large macadamia nut tree, a large Brazil nut tree, a large mango. Then you have these lower trees, such as smaller fruit trees, such as bananas, maybe bamboo. You can eat edible shoots of bamboo. Then you have the shrub layers, so all these different types of berries, flaxseed, other edible types of seeds that are perennials. Then there's the herbaceous layer, even farther underneath, all of the comfrey, the different types of herbs like mint and sage. And then at the very soil surface, there's soil coverage, so different types of strawberries, carrots, other types of perennial vegetables that can grow in shady areas. Then you have roots, other types of root crops that can be grown. And then there's also the vertical layer. These all the different vining crops that can go up into that vine up into the canopy of the trees. So this idea of a food forest is an idea that you can exploit all, not just one layer of crops, right? When you look at a cornfield, for example, everything's at the same level. Whereas in a food forest, you're taking advantage not only of horizontally producing, but also vertically producing, right? Trying to maximize your production while also maximizing the diversity. And then one of the biggest opportunities that I think that comes with this a potential transition to perennial agriculture is that there is an enormous diversity of food crops from perennial trees in the tropics. The tropical ecosystems are the most diverse ecosystems in the world. They have carbohydrate. There's all these trees. When we think of trees, a lot of times we think of fruit and nuts, but there's all these other different types of carbohydrate species. The artocarpus species, such as breadfruit, jackfruit, breadnut. These are essentially like potatoes that grow on trees. They give us all of the carbohydrates we need. Where most people think that carbohydrates only come from corn and beans and other annual crops. Tree species, perennial tree species can provide all of the different types of carbohydrates we need. Then there's an enormous diversity of nuts, pili nuts, Fiji nuts, Brazil nuts. Here in Central America, ojuste used to be this extremely abundant tree that grew along rivers that every year that anytime the corn crop failed, people weren't afraid because they just had to go and gather these nuts that were, that covered the entire forest floor. There's all these different types of vines, oyster nuts. This is Actually, something I bought some seed of oyster nuts. I think in certain parts of Africa, it's called quene, but it's a vining species where you eat these huge nuts that grow inside this vine. Air potatoes, chayotes are another types of perennial vining species. Like we mentioned earlier, the tubers such as taro root and malanga. There's all these different types of leguminous trees that essentially give you beans, edible beans that grow on tree pods. All of the different greens, chipilin, dandelion, sorrel. Estimates from different botanical surveys, like I said in the beginning, are that somewhere around 80,000, there are around 80,000 species of plants that are safe for consumption by food as food by animals like ourselves. We only eat 0.1% of those plants. So again, these are just a few examples, but perennial species can provide our carbohydrate needs, all of the minerals we need, all of the vitamins, nuts, vines, vegetables, tubers, beans, greens. There is nothing that cannot be provided for human nutrition that cannot be provided by perennial agricultural species. So again, what are some of the challenges? Why are we not making this transition back to more perennial agricultural species? Firstly, there are issues, right? It takes time to get these systems established, right? If most, if you're going to plant a nut orchard or a bunch of these like breadfruit trees or other carbohydrate trees, you're going to have a time of transition. They're not going to produce the first year or the second year. You might have to wait 6-7 years before you start receiving abundance of annual production. So how do we help small farmers make this transition? This is a picture, for example, of a transition. Part of the land has been planted into perennial crops, while the other part is still maintaining annual crops. So you don't have to shift. You don't have to shift. 100% from year to year. You can make a gradual transition. What about all these billions of dollars being poured into subsidies? What if we could, subsidize small farmers to help them make this transition, right? Help them, support themselves economically during the years while they're caring for the adoption of these perennial agricultural systems. Another challenge is that, like I mentioned, there's a lot of invested interests of big agricultural corporations. People, these billion-dollar companies want farmers to continue to buy their seed, to buy their fertilizer, to buy their pesticides, right? They're going to, if we were to make a large-scale transition to perennial agriculture, that would mean Monsanto and Bayer and DuPont and all of these big companies would lose their kind of monopoly of the control of seeds, the control of all of this genetic material, which is questionable in and of itself if that's a legal thing for people to patent life itself. And creating the dependence of millions and millions of farmers who have to buy their products year after year after year. If we were to shift to that would certainly affect the interest of this of this economic class. There's also cultural, I would say, kind of barriers or challenges, right? Most cultures around the world, here in the part of the world where I live, if you tell people that they're not going to have access to corn tortillas, people might, start a revolution. In China, you try and tell people that rice isn't going to be the main crop. That's going to be an issue. And I think that we do need to try and move away from an over reliance on perennial grains. That's about, trying to help people understand that wide scale annual consumption of grains needs to be supplemented by this adoption of other types of perennial crops. I think there are cultural shifts that also need to be made, and then also the majority of the foodstuffs that are grown today are grown for a global market, right? So you grow certain types of fruit that are able to be transported long distances. There are thousands of different types of bananas that grow throughout the world, but only one production. It is because it withstands global shipping. It'll stay green for a long time. It won't go bad. So essentially, we're selecting certain crops not based on how healthy they are, how good they are for the ecosystem, how good they are for the small farmer, but how long they can stay unripe as they're transported from one part of the globe to the next. So maybe one of the challenges to perennial production is how we can also at the same time make a shift to more local food systems, deglobalize our food system so that all of these this wide diversity of perennial crops can be made available locally. So I want to end with this: the 25-year Farm Bill. I think that what I mentioned at the beginning, Wendell Berry, he wrote this back in the 80s, and he said we have, in 50 years, by 2030, we can change this. I don't think that. I think we need to be a little bit more urgent than that, right? So let's change from a 50-year Farm Bill to a 20. Agricultural production was dominated by polycultures of perennials, food forests, silvopasture, agroforestry systems. What if our global agricultural systems were sequestering millions of tons of excess carbon dioxide in our atmosphere, creating habitat for other forms of life, producing an enormous abundance of healthy, diverse crops for local markets, sustaining watersheds, supporting small farming communities? I think all of these things are possible. I think that there's an enormous opportunity to transform the livelihood of small farmers, to fix climate change, to restore soil fertility by making this transition. And at the end, I want to leave you all with a question here. What types of perennial crops are native to your community? This is a picture from my farm. This is a crop called chachafruto, which we started growing about 5 years ago. It's a perennial bean tree. And since we started growing that, we don't grow annual beans anymore. This is where we get our beans from. It's from a tree that we grew once, and we're going to be harvesting this for at least the next 50 years. It's an enormously abundant, extremely delicious protein from beans. And this is just one example. So I'd like to end here and open up a time for questions. If I would love to hear if anybody knows of different kind of traditional perennial crops that used to be grown in your towns, in your villages, in your country. But I'll ask Dr. Lambert to